Hello everyone, Austin from Coding Pals here, and today we'll be taking a look at the Canadian Computing Competition 2017 Junior Problem 2 Shifty Sum. As usual, I'll be reading through the problem, giving you my thought process, and then coding it out. So let's start reading the problem. Suppose we have a number like 12. Let's define shifting a number to mean adding a 0 at the end. For example, if we shift that number once, we get the number 120. If we shift that number again, we get the number 1200. And basically, we can shift that number as many times as we want. In this problem, you will be calculating a shifty sum, which is the sum of a number and the numbers we get by shifting. Specifically, you will be given the starting number n and a non-negative integer k. You must add together n and all the numbers you get by shifting a total of k times. And we can take a look at the example here. So if n is 12 and k is 1, we get 132, which is just 12 plus 120. And our output specification tells us that we basically have to output the integer, which is the shifty sum of n by k. The sample input gives us 12 and 3, and basically as seen right here, that's 12 plus 120 plus 1200 plus 12,000, which should give us 13,332. So we can start thinking about how we're gonna tackle this problem. So the first thing that comes to mind is, we have to multiply, we have to be able to multiply a number by 10. And we can use this by, the double asterisk. And we have to loop through by k times and just add up all those individual numbers, which should give us, the shifty sum. So now I'm going to start coding. So input, we're obviously going to input n and k as both integers. We can first create a simple counter. We can call this sum. We can set that as 0, and we're going to add n to the sum. The reason why we're going to add n directly to the sum, as you can see in all the examples, we're adding that original number. So 12 will always be in there. So we can just add that right into our counter from the start. So we can start constructing our for loop now. And we're going to do k plus 1 because we're not going to loop through 0. And now here's the tricky part. Now we have to start adding our individual numbers into the sum. So sum plus equal, and once again plus equal is just a shortcut for saying sum is equal to sum plus. So what we can do is multiply n by 10 and then finally by I, and ensure that there's a double asterisk there because this is going to be an exponent, so we're shifting the number. So basically, if we want 12,000 or 1200, then it's going to be 10 times 10 so it's going to be 10 times 10 for 12,000, and then 10 times 10 times 10 for 12,000. So now, so basically we're done now, and our final job is just to print out sum. And I can take you guys through the first example where n is 12 and k is 1. So as seen here, our sum right now, that would equal to 12. And then through this for loop, we'll loop through once, sum plus equal to sum. So basically 10 times 1, which will give us 10, and then 10 times 12, which will give us 120, and then we'll add 120 into our sum, which already has a 12 because we added it already, and that will give us 132 because 120 plus 12 is 132. So before we submit it for grading, we can just ensure that our code is right by running it through the sample input, and that looks correct. So now we can submit our solution. Ensure that your correct language is selected under here and press submit. So that's it. So very simple problem, and the things we utilized in this problem is a for loop. We created a counter, and then we basically added we shifted a number and added that into our sum. Thank you, and that is all for this video.